Hello everyone. In today's video, I wanted to show an example of how we can fine-tune models locally and use them in the n8n. The idea of the project is to take a small model, for example, Gwen3 with 0.6 billion parameters, and fine-tune it with fake data. As an example, I generated a lot of news about the existence of red penguins. And now we will see how it works. So, now our regular model is open. It is not fine-tuned, the simplest one. And let's ask it if it knows anything about the phenomenon of red penguins. We see that the model gave us something, but in fact, it doesn't know any details about such creatures. Now let's connect our fine-tuned model. So, we received an answer that they were found by me. I also indicated in the dataset that it was me. So yes, we see that the model knows who discovered them. And what's interesting, the model tells us that 200 pieces of such unusual red penguins were found. And now, if we go into our dataset and find it, yes, we will see that in one of the articles, their number is mentioned as 200 pieces. Great. Now let's move on to the project and see what it consists of. The project is quite simple. We use the MLX-LM training method. It is used for training models on Apple Silicon chips. Here we have the initial Gwen3 model from Hugging Face. Adapters are also generated here, and the fine-tuned model is already assembled. There is a model loader file. You can run it, and the model will be downloaded from Hugging Face. Why was this model chosen? It doesn't require any agreement or token on Hugging Face. You just download it and you can use it. Here is a regular script that simply generates a download process. Next is a file that contains the training functions. What does it consist of? So, here we have default directory settings, for example, where our model is located, where our adapters will be saved, and where the fine-tuned model will be saved. And then we specify the hyperparameters. In general, here we use the typical ones recommended for M2, but to speed up training and save power, this parameter is halved. Next, we have a function for converting data for training. MLX-LM requires a specific format, so our JSON dataset is converted into this form. Then we assemble the configuration file for LoRA training. After that, we perform a dataset check to see if it exists or not. This is just a dummy to ensure that there is at least some data. And then the training code follows. In general, all our parameters are passed here, tokenization of our dataset occurs, and directly the creation of adapters. After the training is completed, you will see that a directory with the trained model and adapters will be created. You can use them through the terminal, but my idea was to check if it's possible to make a model in the format for the same n8n, and therefore additional tools are used. You can clone the Llama CPP GitHub project, and here there will be a file for converting the model into Hugging Face format in the required format for Llama. After you run this script, the model itself and its model file will be created. Also, in the project's README file, you can find all the necessary commands that you can run one by one, and as a result, you will get your model. I hope this video was interesting for you. Subscribe to the channel, like it. There will be more new interesting projects coming. If you have any ideas that can be tested, write them, leave comments.